Good morning, class.
Good morning.
Hi, how's everyone doing?
Pretty good. I'm tired.
Oh, you are? Oh, it was a hard night last night.
Yeah.
Stayed up too late playing video games.
No, actually I was watching TV.
Well, we gotta get to bed earlier next time, alright?
Okay.
Okay. Alright. So how many of you think you'd like to design your own tile floors when you grow up so you don't have the exact same floors as everyone else?
Tile floors?
For like your bathrooms or your kitchen?
Oh. I guess I could do that.
Of course you could. Yeah, I think it'd be awesome to design your own too. Do you think we should just pick out random shapes and put them together like this and be like, hey, I like these shapes. I think they should go together?
Yeah! Oh, whoa. Maybe not.
That won't work out, will it? Why won't it work?
Because then you gotta find some weird shape that'll match that one.
Exactly. That just won't work for us, will it?
Nope.
Alright, well, we need to plan which shapes fit together nicely so that we can have really nice looking floors, huh?
I'm hungry.
Lunchtime's after this, and don't worry, we'll be there soon.
Where's the popcorn?
That'll be during lunch, alright? Your mommy packed it for you.
How do you know?
She told me. Alright, let's focus. Here we go. Alright, so after we finish our lesson today, you'll have a better idea of what kind of shapes go well together so that you can have a good pattern for your tile floors. Doesn't that sound good?
Sounds great to me.
Alright. Let's review a couple of geometry terms that we've been using to make sure we are ready to succeed in our lesson. Sound alright?
Sounds alright to me.
Alright, good. Alright. Raise your hand if you remember what a vertex is.
Oh,
Ooh, that's tough, that's tough. Oh.
Hand down, hand down.
Donald, go ahead and share with us what you think. What you remember.
I don't really remember what that is.
You don't remember? Well, yesterday we talked about vertexes, and that's the corner of a polygon. So here's a vertex right here. Does that ring a bell?
Yep. Rings my bell.
Alright, so we've got a lot of vertexes on our shapes right here, don't we?
Yep.
Alright.
Looks like it.
Yep, good thinking. Alright, well, we've been learning a lot about triangles and how to find out what the total measure is inside of it. What are the angles inside of a polygon called? Inside. Sounds like inside is what?
Interior.
Interior, that's awesome, and that's a good way to remember it, right?
Yeah, that's awesome.
Inside sounds like interior, so that
I'm
makes it
just
easy.
so smart.
Yes, you are. Good at remembering. Alright, so after our lesson yesterday, what should the interior angles add up to in a triangle? That's a tough one, isn't it?
Oh, I think I know.
What is it?
180 degrees.
Great job, 180 degrees. And
I'm just a genius.
We can remember that because it's the same as a straight line. If you unfolded your triangle, it'd be like a straight line.
You unfolded it?
Yep. Alright. Well, it's great that we know that what the degrees of a triangle should add up to, but are all the shapes in our world a triangle?
Not really.
No. A lot of them aren't. What's some other shapes in the world that are
Pizza
not
is.
triangles? What shapes of pizza?
A circle, but when you have it in pieces, it is a triangle.
That's true. What other shapes do we have in the real world? How about what's a
Square.
stop sign? A square, yeah. What's the stop sign shape?
Well, it has eight lines, and so I think it might be called like an octagon or something like that.
Yep, and hexagons, and we got all kind of shapes and triangles. But other than triangles, those are some of them. Alright, so triangles don't even begin to cover all the possibilities of shapes, do they?
Nope, not really.
Nope, not at all. Alright, well today we'll be learning about a method for determining the total of all the interior angles added together for regular polygons, which don't worry, we'll talk about regular polygons later in our lesson, so don't panic. It's
Regular.
Okay. Yep,
What
regular.
about an odd polygon?
And
Can we
then
make those?
hold on, wait, pay attention before we come back to this. Alright, and you'll also be able to learn how to determine what each measure of each angle is. Sound like a plan?
I guess that's a plan to me.
Alright, sounds
Yes,
good.
Stan. That's the plan, Stan.
Why do you think it's important that we learn how to determine what interior angles, like what their measure is? Put your thinking cap on.
Can you repeat the question?
Why is it important that we learn how to do this? It's a tough one, isn't it? You want some help? Lifeline?
If it's you, yeah. Because I didn't come up with that question.
Alright, you can use it when you're doing a lot of different jobs, huh? So remember we're talking about our tile floors? Builders might need to know what interior angles are so that they can build their floors, make good shapes fit together, right?
Really?
Yep.
Oh, okay.
And it also makes you a better problem solver. If you can think through these problems, you'll be a smarter person. How's that sound?
I don't doubt it.
Alright, so let's get started.
Okay.
First we need to determine what a regular polygon is, right?
Regular polygon.
Yeah. Well, let's get started then. Alright. What do you
get going?
What do you notice about these two
I got
different
recess
shapes?
to get to.
Two different shapes are both pentagons. So what's different about them?
One's longer.
One's longer. Are these sides the same size?
Nope.
Nope. Are these sides the same size?
I can't see your hands in the way. I think so.
Yeah. These sides are the same size, but these ones aren't.
Equilateral.
That's kind of like a triangle. They have equal sides and equal angles. That's a great way to think of it. So are regular polygons. All the sides and angles are equal. So this is a regular polygon, and this is an irregular polygon. So what is this?
Regular.
Yep, and?
Irregular.
Yep. So when both of the angles and the sides are the same, we call it congruent. Everyone say congruent. Congruent.
Congruent.
There you go, congruent.
Congruent.
There you go.
Congruent.
What does congruent mean again? The same.
The same.
The same. There you go. Good job. Alright, so now that we've learned what a regular polygon is, let's use the triangulation method to find what the total measure of our angles are for our shape. We'll learn why we call it the triangulation. That's a tough word, isn't it? Say triangulation.
Triangulation.
Yep. Triangulation. We'll go over that later about why we call it that. Sound good?
Okay.
Alright. Our first shape that we're going to look at is a...
What is it?
A square! Alright, a square. A square is a regular polygon because it has what?
The same sides.
And?
Same length.
And angles, right? Angles and sides are the same.
Yeah.
Same. What's another word for same?
Congruent.
There you go. Alright, so our first step for this method is going to be dividing our regular polygon into triangles.
Why are we dividing it?
Because we're going to find out the total the total measure of all the angles together.
Oh, okay.
Alright. Alright, let's divide it into triangles. And we're going to connect one vertex to all the other vertex that we can, okay?
Okay.
So it looks like this. Here, we'll hold on to one vertex like this.
Yeah.
We're going to draw a line. Can we draw to this one? Is that going to help us?
Oh,
To
no,
make a
you can't
triangle?
draw that.
No, what about this one?
You're gonna color the air.
Yeah, we don't want to do that. Is this a good one?
Yeah, you can draw that one.
Okay, we'll do that. I'm going to use my
Who needs a
ruler so we can make
ruler?
a straight line.
Oh, I just get tired of that.
Alright, look at that. How many triangles do we have?
1, 2.
2. Yep.
Yes, we have those.
Can we draw any other triangles this way?
Yeah.
No.
Oh, not with that
No,
one.
not with this guy.
Not
Nope.
with that vertex.
Alright, so now that we've drawn our lines first, because we don't want to mess up, we're going to cut them apart with scissors. Safety first, right? Ow! Alright, so we're going to cut our square into how many triangles again?
2.
Alright, we have 2 triangles, so no more triangles can happen, right?
Right.
And alright, great. So now that we've found all of our triangles, we can move on to the next step. You ready?
Yeah.
All right.
Ooh, well, I am ready.
We said that triangles have a total measure of how many degrees?
180.
180. Right there.
Yeah.
And how many triangles do we have?
2.
2. So what can we do to find out how many degrees we have for both triangles?
Multiply.
Multiply. 180 times 2 is what? And if we need to work it out real quick, we
I
can.
thought it was division.
No, multiply, because we want to get a bigger number, because it's the total.
Oh, yeah.
0 times 2 is?
0.
8 times 2 is?
16.
Carry the 1. 2 times 1 is 1. Plus 1 is?
Oh, it's 2. It's 3.
It's 360 degrees. So we can have 360 degrees for this square right here, total.
Yeah.
So now we want to figure out how much each one is worth. How many angles do we have in our shape?
4.
4, right? There's 4 sides and 4 angles. So how do we find out what each one's worth if they're all the same? 360
Divided by 4.
divided by 4 is what?
I don't know.
90 degrees.
Oh, yeah, that's right.
And that makes sense, right? Because we have right angles in our square.
Oh, yeah. Oh, yeah, I see a right angle. What about the left angle?
Nope, just right angles today. Alright, let's move on to our next shape. You ready?
Okay.
Alright, what shape do we have here?
That is a one. A pentagon.
Alright, so let's go ahead and draw our triangle. I'm going to do it real
Isn't
quick.
that a place? Isn't that a place?
Pentagon. Yes, there is a pentagon.
Wait, why did you cross it?
What? What's wrong with that?
Is it wrong?
Yeah, good eye, good eye. You have to, you have to start from the same vertex. Our lines can't cross like that, right? That's too many triangles. Look how many triangles that is.
Just show it off over there.
Too many triangles, right?
Yeah.
All right. So it's okay if you mess up, because guess what?
What?
You can have another chance on the backside.
What if we mess up on both sides?
Then you can use a different color marker. So let's hold our, so we don't mess up again, let's hold our pentagon at the top, and we'll use
Okay.
that to draw from the same point. So we
Yeah.
don't cross lines, right?
No, yeah.
We don't want to cross our lines.
No, we don't.
Too many triangles.
Too many triangles.
Exactly.
Exactly.
All right.
Okay.
All right. How many triangles do we have now?
I don't know. I can't see that. 1, 2, 3.
3. Oh my goodness, I noticed a pattern.
What?
How many triangles do we have in our square?
2,
2. And how many sides are on a square?
4.
4.
So you minus 2.
You minus 2. Good job, because we have 3 triangles on our pentagon with 5 sides.
I am roll.
All right, so now we are ready. You are on a roll. Excellent job. I'm so glad you're paying attention. You're so smart and helping us out. All right, we're going to
I
cut
get from
our...
mommy.
Oh, yes, your mommy is very smart. All right, let's cut our triangles apart, all right?
Okay.
All right. Got our 3 triangles. So now what should we do? What's the next step?
Oh, 180
180
times 3.
times 3, right? Because we have
Because there's 3 different triangles.
Excellent job.
He stole my idea.
Oh, well, I'm glad you're both so smart.
But
180 times 3. So let's go ahead and write that out. 0 times 3 is?
0.
8 times 3 is? Yup, 24. And 3 times 1 is?
3.
Plus 2?
5.
540. That's our
Wow,
total
that's a
degrees
big
for our
number.
shape. Now, if we want to find out what each one is worth, what do we do?
Divided by. Oh, you messed up, teacher.
Yep, it happens. Divided by 5, right?
Yeah.
And we get 108 degrees.
Oh, that's a weird number.
108 degrees for each side of our pentagon. All right. Sound
You
good?
even get 108.
Got it?
Yeah, I guess.
Next shape. Last one for you
How
to do
many
it
shapes are we
all by
doing?
yourself.
Okay, good.
All right. You ready for the last one?
Yes, hurry, let's go.
You ready for our mystery shape?
Ooh, mystery shape. Mystery shape. Mystery shape. Let's get it.
Okay. What do we have here?
Ooh, wait, 1, 2, 3, 4, 5, 8.
Is a
Like an octopus is an octagon.
oh my god, like an octopus. There you go. So what should we do first to find our total degrees?
We have to find a 1 at the very top.
Okay. So this one sound good?
Yeah.
All right, now
no,
what?
1 over.
Oh.
Yes.
Great. Now what?
Now you have to draw the lines to all the other sides except for the ones that don't touch it. That do touch it.
Oh, good idea. That's a good way to think of it, huh? I'm going to do the ones that.
Because you would be writing in the air. I already told you, teacher.
Yep. All right. And should they cross at all? Should the lines cross at all?
Nope.